we're in 7.6. We're going to do example 2 together. Just a couple of these I want to try with you, and then when we get to example 3, I'll do a couple and then let you do a couple for extra credit. All right, so steps for factoring polynomials. First thing we need to do is we need to check for a GCF. We need to pull it out. If we see a GCF other than 1, we need to pull that out. Now, if your GCF is exactly 1, then don't worry about pulling out a 1. That's a waste of time. You don't need to pull out a 1, okay? Definitely, if it's a number other than 1, pull it out. So a number other than 1 or variable, that's a GCF. You need to pull it out and start your problem that way. Okay, now number 2, once you pull out your GCF, if you need to, then check to see if you have a trinomial. See if it's a perfect square trinomial, and then factor it if it is. If it's a difference of 2 squares, if it's a binomial, see if it's a difference of 2 squares, and then factor it accordingly. Now, if your trinomial happens to not be a perfect square trinomial, then just factor it the good old-fashioned way we did, factor by grouping. And then do a final check. Look for common factors. Did you skip something? Did you skip a GCF, or did you forget to factor something that needed to be factored? Okay, that's always a good thing to look for in that final sweep. Okay, let me show you letter A, and I'll kind of talk you through it, make sure it makes sense to you. All right, letter A, first thing we want to do is we want to look for a GCF in all 3 terms. Okay, what number, what variable or variables are common to all 3 terms? Now, hopefully, you know I don't like a leading negative number, so I'm going to pull out a -2, because that's common to all 3. -2 is a factor of -2. It's also a factor of 16, and it's also a factor of 32. And then notice that there's an x in all 3 terms. I'm going to pull that out as well. Can't pull any y's out. That last term, 32x, does not have a y. So therefore, y is not common to all 3 terms. All right, so let's see what we left behind. -2x times what is -2xy squared? That would be y squared. You nailed it, okay? -2x times what is positive 16xy? That would be -8y. And then -2x times what is -32x? And that would be positive 16. Okay? Now, if you're not sure about the signs, just kind of go back through, look at it again. A negative times a positive, there's your negative. Okay? A negative times -2 times -8 is positive 16. -2 times positive 16 is -32. So if you're just kind of like, I don't know how she got those numbers, hopefully you were tracking me. If not, slow me down tomorrow in class and let me show it to you again, okay? Let's see here. We pulled out the GCF. Now, step 2, we have a trinomial. So let's check and see if our trinomial is a perfect square trinomial, okay? Y squared is perfect. 16 is also a perfect number, and 16 is positive. This has the makings of being a perfect square trinomial. Now, how do we factor that? Well, you're going to do some quantity squared. It's a binomial that you're squaring. So we're going to take y squared, and y times itself is y squared, so we're going to put y in the first position. What number squared is 16? 4. Then I let the sign in the middle in front of the 8 is minus, so I'm going to put a minus sign here. Now, probably off to the side, you're going to want to just double check that. Make sure it's a perfect square trinomial, okay? So remember, we took out the greatest common factor. That was -2x. And then we factored the perfect square trinomial. We think it's a perfect square trinomial, and we just want to double check that. So somewhere off to the side of your paper, just do your 3 steps. Y squared is y squared. Y times -4 is -4y. Doubled is -8y. And -4 squared is positive 16. Yes, it is. And I am fully factored now. Okay? I do not have a GCF in my quantity y minus 4. Everything looks fully factored, okay? It's going to take you a little while to get the hang of this. That's what I want to show you in example 2, do a couple in example 3, and then let you try some, okay? Let's look at B. Let's first look for a GCF, okay? That's always your first step. Is there a GCF I can pull out? So my numbers are 4, 16, 16, so I can pull out a 4, and my x's are x cubed, x squared, and x, so I can pull out an x. Let's see what's left. Looks like x squared is what's remaining from the first term. 4x remains from the second term, and 4 from the third term. Okay, now let's look at the trinomial that's left. Step 2 says, hey, if you've got a trinomial, hey, check and see if it's perfect. Hey, you know what? It looks like it is. It has all the makings of being a perfect square trinomial. So let's factor it that way. Remember, x squared, break that up by multiplying x to itself. 4 is 2 squared, right? And then the sign in the middle is positive, so I'm going to write that as positive. Now, I would double check that x plus 2 squared, just to make sure it's exactly what it purports itself to be. So let's do our 3-step check. Square the first term, so that's x squared. Multiply x times 2, then double it, so that's 4x, and then square the 2, and that's 4. So yeah, we definitely factored it right. There's nothing else I can do here. I don't have any other things to do. I don't have any more trinomials. I don't have a difference of 2 squares. I pulled out my GCF. Looks good. And I'm done. And I box it in. All right, let's look at C. I'll do this one with us. Remember, first step is always look to pull out a GCF. It'll look a lot better if you pull out a GCF. Otherwise, you're going to just stay confused. Okay? Both terms have a 2 in it, and both terms have at least one y in it. So that's our GCF. Let's pull out, let's see what's left. It looks like I have x squared minus, and then it looks like I have y squared. Now this time I don't have a trinomial, okay? I don't have a trinomial, but it looks like I have a binomial. Let's check and see if it's a difference of 2 squares, okay? Let's see if it's a difference of 2 squares. First term, x squared is, yeah, that's perfect. That's a square. Y squared is a square, clearly. And I have a subtraction sign in the middle. So that appears to be factorable. I can go one step further and factor that difference of 2 squares. Remember, the quantities are identical. The only thing that's different is the sign in the middle. So x squared, we'll put one of them here, one of them there. Y squared, put one of them here, one of them there. Make one of the quantities positive, the other one negative, and you're finished, my friends. This is as good as it gets. That's fully factored, okay? So all 3 of these were special situations where we pulled out a GCF, and they were either a perfect square trinomial or a difference of 2 squares, and we factored those, okay? So we'll practice more of those tomorrow. Come with questions about this.